there, we're going to work on the algebra review for geometry pre-AP. We've selected a few problems that we think you will benefit from. So the first 4 problems are all one-step algebra problems that you will use inverse operations to solve. By inverse operations, I mean the opposite of the operation that's happening. So for example, here, the operation is addition. So to undo this or to isolate that variable, you would subtract on both sides of the equation. And that cancels over here, and you end up with a equals 6. For question number 2, the operation is division. So to undo division, you would multiply, of course, on both sides of the equation. So in this case, those two cancel, and you get x equals 28. For number 3, the operation is subtraction. So to undo that, we would add 5 seconds to both sides of the equation. All right, these cancel over here, but 6 and 5 seconds is going to make kind of a mixed number, right? So the easiest thing in my view to do is to make 6 into 12 over 2. That way it has the same denominator as the 5 seconds. So then I can add them together, and one answer is t equals 17 over 2, or if you want to, you could say it's 8.5. Okay? For number 4, the operation that's happening is multiplication, but you're multiplying by a fraction. So you could divide, but it gets kind of complicated. Instead of division here, I'm going to ask that you multiply by the reciprocal, which means flipping that fraction upside down on both sides of the equation. So the 5's cancel, the 3's cancel, and you end up multiplying 2 times 3/5. So your answer there is that x equals 6/5, or if you wanted to put it as a mixed number, 1 and 1/5. Okay, let's go ahead and look at number 7 down here. Again, you're using the same principles of inverse operations, but in this one, you got a 3 on the outside of the parentheses. So before you do anything, you want to distribute that 3 across the parentheses. So 17 equals 3p minus 15 plus 8. Then, of course, you want to combine like terms. So I've got a negative 15 and a positive 8 right here, and I end up with 17 equals 3p minus 7. Of course, I want to start getting that p alone, so I'm going to add 7 on both sides. 24 equals 3p. Those cancel. Divide by 3 on both sides to get p completely isolated, and you get that p is equal to 8. All right, the next question is number 10. And this is very similar. All the x's are on one side of the equation, so clearly we're going to have to combine terms. Before we do that, we've got this negative symbol here. And I like to think of it as sort of distributing that -1 to this parentheses. So -1 times x and -1 times -1. So I'm going to rewrite this equation as 5x plus 16 minus x plus 1, and that's equal to 38.6. Then I want to combine like terms. I've got a positive 5x and a negative 1x, and I've also got a positive 16 and a positive 1. So I'm going to end up with 4x plus 17 equals 38.6. Then, of course, I want to start isolating that x. So I'm going to subtract 17 from both sides, and I get 4x equals 21.6. Divide both sides by 4 in order to get x alone. Now, this divides kind of nicely into a decimal. It divides into 5.4, or you could write it as a mixed number, which is 5 2/5. Okay. Next, we're looking at question number 12. Now on this one, you got the x's on both sides of the equation, so you're going to have to do an inverse operation in order to get them to the same side. So what I chose to do here, this is 3/4 x and this is 1x essentially, right? So what I'm going to do is I'm going to subtract, because that's the opposite of addition, 3/4 x on both sides. Okay, so if I take $1 and I take away 3/4, I'm left with 1/4. So 1/4 x equals 7. All right, now I've got to do that multiplying by the reciprocal. So I'm multiplying times 1/4. The reciprocal is going to be 4/1. Now, when I do that over here, everything cancels. On the other side, multiplying times 4/1 is the same thing as multiplying times 4. So it's really 7 times 4. And in this case, x equals 28. All right. Ooh, we're on to the back of this paper already. All right, number 19 is the one we're going to look at next. And this is a relatively simple one. This time, though, they want our answers rounded to the nearest hundredth. So if there's a decimal in there, that's totally okay. Hundredth is 2 digits after the decimal place. Number 19. We're going to do inverse operations here again. But the inverse of squaring something is to find the square root. So to find the square root here, the x gets alone, and then you've got the square root of 25. Now, when you put this in the calculator, typically you come up with that x equals 5. But another way that you could get the square root of 25 is to square a number and get to 25 is to say that x equals -5, because -5 times -5 is also 25. Remember, this is one of those kind of quadratic equations that has more than one solution. All right, number 22 is to solve by factoring. And if you'll remember, factoring is when you take those quadratic equations and you break them apart into two binomials, right? So those first factors are x's, and then these second ones need to multiply to make 2. So the only numbers that go into 2 are 1 and 2. And everything is here has got to be positive because both of the signs have got to be positive. All right, so those are the two factors, but remember it says solve by factoring. So this whole equation, x squared plus 3x plus 2 equals 0. That means that each of the factors can also be equal to 0. So I'm going to split this down the middle, and I'm going to say x plus 1 equals 0, and then I'm going to say x plus 2 equals 0. And then I'm going to solve for x. So to get x alone here, I subtract 1. X equals -1. And then to get the solution over here, I'm going to subtract 2 on both sides. So x equals -2. And these are what are known as your solutions. All right. Up here, these were factors. So you factored first and then you solved. So the solutions are -1 and -2. All right, try the rest of those problems and make sure you have fun.